Hey, greetings peeps, and welcome back to Logger Pro. What I'm going to show you this time is how to track motion data captured on video. In this case, we're looking at a free fall situation of a ball, okay? So this was done in the gym, and we're going to go to Insert Movie, because that's what we captured. And we have three choices here. We have volleyball, medicine ball, and basketball. I'm going to choose the basketball. We did 3 drops from the gym. And there we go, our friendly volunteers waiting to drop one of the balls here, in this case the basketball. What I'm going to also do in the bottom right corner is turn on my tools for video analysis. You see how they click in, out, in, out, in. We want them in like that. The next step is to play the video, and hey, there it goes. And what I want to do is find that very first frame. So I'm going to go play and stop. Okay, the very first frame where we see the ball just about roll off the bleachers. So I can see that about right now. If I go forward, it's just about to leave the cliff. So I think right here is where it is. This is definitely an estimate. Next, what I do is set an origin. So I want to click Show Origin so I can see it. And here is Set Origin. So I click on that. And I then click, in this case, I want the origin to be at the center of the ball. All right, so I click the center of the ball, and you'll see that there's a crosshairs in yellow. And because the camera was slightly tilted, we want to adjust that, okay? So horizontally here is the x-axis, and vertically is the y-axis. Well, this motion is vertical, so we'll go and keep that convention so that we'll actually look at the y movement rather than the x movement for this particular type of motion here. All right, so I can move this around, and I want to align it. I'm kind of aligning it with the bolts that are in the bleachers like that. Okay, so that's pretty good. I want it as best as possible to give myself a vertical reference. Remember, the camera's always slightly tilted perhaps. If I spent much more time, maybe we could have gotten the camera better, but this compensates. So I'm going to turn that off. Okay, and now what I want to do is set the scale. Okay, so I turn on Show Scale over here in this button, and this button here is Set Scale. So it's difficult to see, but I can see it pretty well. There's a meter stick on the ground, and that meter stick gives us a horizontal reference, but it also gives us the size. So it's telling the program, Logger Pro, that this is 1 meter, because it has no idea how big anything is. So we want to tell it that this distance here, that is 1 meter, and it even asks, what distance is this? And it defaults to 1 meter. 1 in the units meter. So I hit OK, and it's all good. The next thing we do is, with this first frame, since we're at it, we will go here to sync movie to graph. We want to tell it that this is time 0, so it's going to forward it. So this menu comes up here, and this is actually about 1.5 seconds into this movie. And so we want to say that, hey, we want to start the graph here. This is 0, okay? And therefore the graph will start at this moment, which is terrific. So we will hit OK, like that. Now comes what I call the dotting. This is like creating the Phineas trail. We're going to do it sort of invisibly first, then the trail will reveal itself quite magically, okay? So over here, add point is what I want to do. And I'm going to click on that. And I get more crosshairs. I'm going to click on the middle of the ball. It advances a frame, and I want to click on the middle of the ball. Again, each time I click, there's an automatic advanced, okay? So I keep doing this for a while. And in a few moments, what you'll see is the end result. And here we are. I wanted to save you the tedium of seeing me click all these times on the center of the ball, so I'm just leaving the last few right now. So I'm going to click the center and click the center, and I think we can maybe safely click one more before the bounce up, and so there we are. Okay, now what I can do is reveal the trail. So I go to this option here called Toggle Trails, and ding, there they are. There are the Phineas dots. Hey, okay, we've made it. And look at them. They have this characteristic pattern that we should recognize, close and bunched up, and then getting wider, 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 up until the very end where it hits the floor. What does this mean? Well, this is indicative of acceleration because the displacement after each and every moment is getting larger. Okay, this is totally acceleration. This is what gravity does. It will accelerate an object vertically downward. So this is something we've mapped using Phineas poops over here. Okay, that's why this program is really awesome. Now, if you did screw up the poop, well, what can you do? You can go here to select point, and if I hit Option and click on it, I can select it, and I could delete it, and I can delete that one and stuff, and just hit delete. I hit the Option key, at least on the Mac, it worked that way. If I go backwards a little bit, it gives me these interesting options. I want to go and redot them actually. And okay, so next frame, we'll go back here and we'll finish up the dots so that we can use them in the next piece, and that's looking at the table, okay? And so here it is. I've already made the table shorter so we can see Y and VY, all right? And if we go to table options, you'll notice you can also see X. And the reason why I removed X is because it kind of cluttered things up. We don't want to analyze the X motion. The one we're interested in is the vertical motion. And vertical motion is often represented by Y. Not exclusively, but that's convention. And in the downward case, it's going to be negative. And why is it negative? Well, simply because up tends to be positive. So now if we go over here to the graph, we see some cool stuff. Actually, we see X and Y, and I want to change this. So I'm going to go over here and select more, and we get some options. I want to take X off, although it's somewhat kind of neat that we see it also. It doesn't change position left or right, so that is a straight horizontal line. See that? Like this. The only thing that's changing position is Y, and so what I want to do actually is just look at that by itself. All right, so here it is, and now I'm going to go to something called Analyze and Tangent. And Tangent's cool. I'm going to make this a little bit bigger for you to see. Instead of 16, we like the 24. Hit OK. Hit OK. There's 24, so now we can read it. And so if I click, every moment here, it tells me what the slope is based on the data. Notice the slope is getting larger in the negative direction because of the negative direction of Y, downward. And so with the slope, we can get this to kind of look at the instantaneous acceleration. Notice that the velocity, or instantaneous velocity I should say, but notice that it's increasing because the slope is getting larger, steeper, therefore there's an acceleration. All right, and this curve is as a result of the steeper slope. So slope really does matter here, okay? So that's cool. Okay, we can see that. So now I'm going to switch this to Y velocity. And so now we have the Y velocity plotted, and I notice that it looks very much like a straight line, which is great because this would be indicative of constant acceleration. This is a V versus T graph, velocity versus time. And so the straight line that's here, although there's a little bit of noise, maybe the dotting wasn't perfectly centered each time, but it's really, really close. So we can take the slope, and that would be a great averaging technique. Well, how do we do that? We back to selecting the data and go to Analyze and Linear Fit. And what we see here, I'll make this a little bigger for you to see again. We'll go to 24, 24, appearance, 16 to 24. Pow! Pow! There it is. Okay, it says that the slope is negative 9.9 and some change meters per second, which is meters per second squared, which is acceleration, okay? So it's really, really close to the established value, just a little off from 9.8 meters per second squared. So this is really good data that we collected that shows that the acceleration of gravity is totally around this value. This is really acceptable. Look at the correlation, 0.999. This is essentially, statistically, a perfect linear fit. So this is this data would say that it's constant acceleration, absolutely, and the value about 9.9 or ish meters per second squared in the down direction. And there you have it. So Logger Pro comes through again as this awesome tool, this time for video analysis of motion. And I'll leave it to you to explore this, and there'll be activities and opportunities in terms of extra credit for you to take advantage of. So with that, I say, more at in Logger Pro, out.